Lesson 6.5, Inverse Trigonometric Functions. This is the lesson that we were supposed to do from last chapter, but ended up getting skipped. And so we're going to take a look at it now in this chapter before we head into our lesson on solving equations. So, let's say I ask you to solve this for a. So we have the cosine of pi over 3 equal to a. Now, this isn't that difficult to figure out. You could either work it out in your head, or you could flip back to your unit circle trig chart, and you would find out that a would be equal to 1/2. Okay? All right, so that's pretty easy. That's based on things that we've already been doing and we know. But what if I want you to solve this instead? So now our variable is the theta. And basically what this is saying is the cosine of what theta, what angle, will give me an answer of 1/2. Okay, well, with like any equation, we need to be able to undo certain functions in order to be able to isolate our variable. So in this case, what we need to undo is the cosine. And the way to undo the cosine is with something called the inverse cosine. And the notation for that is COS to the -1. Now we used this a little bit in our last chapter when we were trying to work out some problems, but we want to take a deeper look at this now and think about it in terms of it being a function. And so this inverse function is what I would technically need to do to both sides of this equation in order to get to just my theta. So it would look something like this. The cosine inverse of the cosine of theta would equal inverse cosine of the 1/2. Okay, so here the inverse cosine and the cosine are going to cancel each other out. Okay, that was the whole purpose of doing this. And so what we end up with then is that theta should equal cosine -1 of 1/2. So in other words, inverse cosine of 1/2 should equal our theta, which represents an angle measure. And this still means the same thing as what this did. So this still means, what is an angle that if I took the cosine of it, I would get 1/2 as an answer? Okay? Now, based on the previous slide, that seems like a fairly obvious answer. But take a look at your chart. Look at the cosine. Let's do this here. Okay, so let's take a look at this row right here with cosine. And let's look for all of the times when we get a positive 1/2 as an answer. So we get one here. Is that the only place that we get 1/2? Hopefully you realize that it's not. We also get a positive 1/2 right there. So, when we're talking about an inverse cosine, if I'm taking the inverse cosine of 1/2, I not only could get an angle of pi over 3, I could also get an angle of 5 pi over 3. And that's just in one rotation or one period of the cosine function. If I keep repeating and continue to rotate around the circle, then I would probably get even more angles where I would get a 1/2 for the cosine. So if that's the case, then can we really say that theta being equal to the inverse cosine of something is a function? Because we're saying that, okay, I put in, my input was 1/2 for the A. My output ended up being at least pi over 3 and 5 pi over 3. And that was just in one rotation. Again, we might even have more possible angles that would give us a 1/2. So for this single input, I'm getting at least 2 different outputs. Does that meet the definition of what a function is? Well, hopefully you remember your definition of a function and you realize that no, it does not. A definition of a function says that one input value can only give us one output value. There's only one possibility that we can get as an output for any given input. And in this case, this one input gave us at least 2 different outputs. So as it is, this is not a function. And yet the title of this lesson is Inverse Trigonometric Functions. So there must be something that we can do that can take this equation and turn it into an actual function so that we can use it using function kinds of rules and considering function kinds of characteristics. And so that's what I want you to think about for class tomorrow. I want you to come up with some ideas about how can we make this a function. Okay, think about it, be creative, but I want you to think about what you know about cosine. I want you to think about what you know about the unit circle with regards to cosine. Think about your cosine chart. You can think about the graph of the cosine that we've been working with this chapter. Think about whatever you need to with regards to cosine, and I want you to be creative and come up with some way of how we can make this equation, which clearly right now is not a function, how can we take it and make it a function? Come with some ideas for our next class. We're going to talk about them at the beginning of class and use them for our actual lesson in class. So think about this, be ready to share some ideas, and we will see you next class.